Today we're going to look at the greatest integer function from 2.4, page 97. This problem is not in your book. If f of x were to equal, in your book it says int. This is the same way it looks on a graphing calculator of x. Sometimes this function is shown with double brackets around x. It's also nicknamed a step function because of the way the graph looks. It looks like little stair steps. Okay, so if we are going to draw, let's make our table first. We have x, and then I am just going to put int of x. This is the same thing as y or f of x, because then I'm going to use this table to show you a difference. We're going to use the most common values for x: -2, -1, 0, 1, and 2. Oops, and 2. Now, for a greatest integer function, it means every value, it's like you chop off the decimal point. So if I were to plug in -2 for x, the greatest integer would be -2. If I were to plug in -2.1, it would still be -2. It's like you chop off the decimal. And if I were to plug in -2.2, it'd still be -2. All the way up to -2.9, it would still be -2. But once I get to -1, the greatest integer is -1. All the way up from -1.0 through -1.9, it stays at -1. And then once I hit 0, it's at 0. So these, remember, are not points. They are little stair steps. Okay, so let me get our graph on here. Here's our y-axis and our x-axis. Okay, let's do -1, -2. Let's make this a little bit bigger. Alrighty. Now that we have our x, y axes, when I plug in 1, remember, any value from 1.0 through 1.9 has the value of 1. So here is what these actually look like. If I were to start at -2, -2, I put a dot. Then I draw a horizontal line because -2.1 through -2.9 includes this. And then I write a circle once I get to -1. Then I go -1, -1, put a dot, -1.0 all the way up to -1.1. Then I put a circle right at 0. Then for 0, 0, put a dot, all the way flatlined, and then circle. Put a dot at 1, 1. Remember, 1.1 all the way through 1.9, it's flatlined. And then it's a constant. Once I get to 2, it's a circle, and then it jumps up to 2, 2. All the way, and then we put a circle. Now, let me change colors. Let's do a red. Okay. What if I were to take my table? I'm going to add to it. Alright. And right here we're going to put int of x, but what if we had a 3 out front? Now this is very similar to one of your problems. that you are going to be working on? Well, this just means 3 times the greatest integer function. So instead of this being -2, I would take 3 times -2 and get -6. Okay, so that means at -2, let's go to the graph, when x is -2, we go down to -6, we put a dot, and it will stay constant until we get to -1. Then it's a circle, and it's going to go up. All right, then we took -1 times 3, and we get -3. So we have the point -1, comma, -3. So if we go to our graph, -1 down to -3, here is where we put our dot, and it's horizontal until we get to 0, then we circle. Well, at 0, we have the greatest integer would be 0. Take 3 times 0, and we still have 0. So this one has not changed position. It is still here. Now for 1, the greatest integer of 1 is 1, but when we multiply it times 3, we get 3. So a number in front here means that it's going to stretch it vertically by whatever this number is, by a factor of 3 in this case. So I go from 1 to 1 comma 3, put a dot, and then a line, circle. Then we take and find the greatest integer of 2, which is 2. 2 times 3 is 6. So we start with the point 2 comma 6, so 2 up to 6. Put a dot, line, circle, and here we have it, 3 times the greatest integer of x.